Hey everyone, today we're taking it back to the basics with rational and irrational numbers. Let's get started. Alright, so what are rational numbers? As spelled out here, rational numbers are any type of number that can be represented as the ratio A over B. And there's some rules concerning the ratio A over B. In this case, B cannot equal 0. So you can't have 5 over 0. That wouldn't be eligible to fall under the category of rational numbers. And we also have to look at the fact that A and B are also integers. But hold on, what are integers? Integers can be represented as all the numbers on the number line going in both the positive direction as well as the negative direction. However, they don't include fractions and decimals. So 2.2 is not an integer. Negative 8 over 3 is not an integer. However, negative 2 is an integer. Negative 816 is an integer. Positive 18 is an integer. Negative 19 is an integer, and so on. So since we're here, let's go ahead and cover all the real numbers. So next on the list, we have whole numbers. Again, they don't include fractions or decimals, but this time they only go from 0 to infinity. So starting from 0 and onwards to infinity.
To infinity and beyond!
So 0, 1, 2, 3, 1,000, 1 million, 1 billion, and so on. Finally, we have natural numbers, and basically natural numbers are all the numbers that you can count basically on your fingers. Again, they don't include fractions or decimals. So starting from 1 all the way to infinity. So 1, 2, 3, 10. If you want to count with your toes as well, I guess 20, and so on. So from 1 to infinity.
To infinity and beyond!
Alright, so quick recap before we continue. So we have our natural numbers going from 1 to infinity. But what about 0? So our whole numbers cover that. So 0 to infinity. But what about the negative numbers? Our integers include that. So we have our negative infinity to positive infinity. And what about our fractions and decimals within our negative infinity to positive infinity? Well, our rational numbers cover that. So they go from negative infinity to positive infinity, but also including our fractions and decimals. But wait, there's more. So the mathematicians of the past apparently weren't satisfied with rational numbers, so they decided to add irrational numbers. I know, right? Sorry, I can't do anything about that. However, I do know that irrational numbers are basically numbers that can't be written in the ratio A over B. So numbers such as pi, 3.14, and I said the square root of 2, the square root of 3, they can't be written in the form A over B. Alright guys, let's look at some examples of rational and irrational numbers. Here we have some rational numbers here. We have half, negative 18, 9, and then 0.586. Now why are these rational? These are mainly rational because we can put them in the format or ratio A over B. Half, for example, is represented as 1 over 2. What about negative 18? Well, we can represent this as A over B because if we put negative 18 over 1, so we have negative 18 over 1, that's represented as A over B. How about 0.586? Well, if we put 0.586, we can also represent that as 586 over 1,000. So 586 divided by 1,000 will actually get you 0.586. Well, what about 9? Well, we can represent 9 by 27 over 3. Because when you divide 27 by 3, it'll get you 9. Alright, let's look at some irrational numbers. So here we have negative 7.77 continued. We have the ... We have our pi symbol. We have the square root of 2, and we have a 0.3 with the line over the 3. Let's look at why these are irrational. Negative 7.77 continued doesn't have an ending. That's why we had to put the 3 dots here to show that it still continues. So it can go from here all the way to the grocery store and still not stop. So the negative 7.77 wouldn't be able to be put inside the ratio A over B because it has no end. Let's look at pi. Pi, as some of you know, is an irrational number that also has no stop. We classify it as 3.14, however, it goes on continuously. I'll put the real number right here. So you can read it, and yeah, pi goes on continuously, so therefore we can't put it in the ratio a over b. How about the square root of 2? Just like pi, it goes on continuously. Here it is right here. The square root of 2 keeps going continuously and it doesn't stop. How about 0.3? Looking at 0.3, we know that there's a line on top. Whenever you see a line on top of a number like this in math, especially when it's a decimal, just know that that number goes on continuously. So 0.3 can be represented as 0.33333 and so on. It won't stop. Considering irrational numbers, one rule that you always need to keep at the back of your mind is that they need to have like terms. Without like terms, you cannot add irrational numbers together. It just won't work. Here's an example. Here we have 7 root 3 plus 7 root 4. Now, looking at this the first time, you're probably thinking just add the 7s and add the 3s and the 4s, and you should get 14, maybe 14 root 7. However, that is not the case. One thing you have to notice is that these terms are not alike. We have a root 4 here and we have a root 3. You can't just add these up because they don't share the like terms. However, if we had something like 8 root 3, so we have 8 root 3 minus 4 root 3. Because these are like terms, we can go ahead and just take our 8 and our negative 4 and combine them, and that will give us a 4 root 3. We have our 4 root 3. The only way this can be possible is if we have like terms. So here we have our root 3 and our root 3. Therefore, this is possible. However, if we don't have like terms, this cannot be done efficiently. When adding rational numbers or subtracting or multiplying or dividing, all you have to make sure that you are careful of are the signs as well as the fractions and the decimals. Let's take a look at some examples. So here we have negative 9 plus 8. This is also the same thing as saying 8 minus 9. So this will give you a negative 1. Here we have half plus half. Make sure your denominators are the same. And I'll go into further detail as to what I mean by that. So you have your half and your half. That adds up to 1. Here we have 0.8 plus 2. That adds up to 2.8. But now let's say we weren't really too generous or we weren't really too lucky to get denominators of the same type. What do we do then? Alright guys, so as you can see here, we weren't so fortunate with getting two fractions with the similar denominators. Now, what do we do when we have two rational numbers like this and we have to get them together? Well, the first thing to do is to get their denominators to be the same. How do we do that? We multiply each fraction by the denominator of the other fraction. So let me demonstrate. So we have 3 over 4. So we're going to multiply this whole thing by 3. So multiply the numerator by 3, multiply the denominator by 3. So you end up getting a new fraction, which is going to be 9 over 12. We have a plus sign. Now we're going to do the same, but only on this side we're going to multiply it by our 4. So times 4 and times 4. So now all we have here, 4 times 2 is 8. And then our 3 times 4 is 12. Then from there we can go ahead and add this. So 9 plus 8 is going to get us 17 over 12. We have our 17 over 12. Or you can also put this as 1 and 5/12. 1 and 5/12. So that was what you would do in case you have two fractions with different denominators. Alright guys, so now we have division and multiplication of rational numbers. So what we'll do here in this sense, when you're multiplying two fractions, which are rational numbers, all you'll do is just multiply straight across. So 3 times 2 is 6. 3 times 2 is 6. And 4 times 5 is 20. 4 times 5 is 20. So 3 over 4 times 2 over 5 will give you 6 over 20. And this again can also be simplified to 3 over 10. So in math, always try and simplify your answers to the simplest possible answer. And here we have 3/5 divided by 6/8. So what we'll do in this sense here is whenever you're dividing fractions, our goal is to multiply them. So what we're going to do is we're going to flip the sign. So we're going to have 3/5, but this time times Now with the second fraction, we're gonna flip it. So it's gonna be 8 over 6. So we have 8 over 6. So 3 times 8 is 24. And 5 times 6 is 30. So now we know that 3/5 divided by 6/8 will give us 24 over 30. But then we can go ahead and simplify that to, so 24 divided by 2 is 12. And 30 divided by 2 is 15. And this can even be simplified more because 12 divided by 3 is also equivalent to 4. 12 divided by 3 is 4. And 15 divided by 3 is 5. So we end up getting 3/5 divided by 6/8, which is the same as 3/5 times 8/6, is going to give us 4/5.